So this is a review for your Chapter 7 test, and I'd like you all to start with this problem. And if you can factor it, you should, of course. Then figure out the horizontals, the verticals, the x-intercept, the y-intercept, the whole, the domain, and find 3 points that are on the graph. I'll pause for a second while you work on that. Okay. Is it a Bob, Sob, or a bot? It is bigger on top, so what's the rule for that? No horizontal asymptotes. Okay, how about vertical asymptotes? Is there? Thank you. Is there any vertical asymptotes? Seems like there should be, but no. The thing that's on the bottom there, the -4, that one does not create a horizontal asymptote. What does that -4 create? A hole. Okay, so there isn't any horizontal or vertical asymptotes here. All right, how about the hole? Where is it at? Well, if you just said -4, you're on a good start, but you can't have credit for that. Because why? Because when this thing simplifies down to is, just a second here, please. We would factor the top and the x plus 4s cancel. Can you tell me what you get after you canceled the x plus 4s?
Then you get x minus 1 parentheses.
Thank you. So there's my function after canceling stuff. I call that the simplified function. Okay, so that's the simplified function. That's what it looks like, except it's also got a hole at -4 comma what? Well, you put the -4 right here, and you'll have -5 times -4 is +20. Who had -4 comma 20? Awesome, that is correct. That'd be one of the points you should put on your XY chart. Think about it. -4 comma 20 is important. I'd just put hole after it because you can't put a normal spot there. But all right, where do I get my other points? Might as well put it into this one too. Isn't that a lot easier than the other one? And it'll work. Okay, so let's put in some numbers. Give me a point that you put in there, Aiden.
I forgot to do that part.
Okay, I'll come back to you later. Tyler.
-1.
-1, and when you put in the -1 here and here, you should have had -2 times -1 is +2. You are correct. -1 comma 2. Taddy, give me a point. Yeah, sure. -5, and then what goes into that? Or sorry, what do you get when you put that in? Good. Okay. Do you have another point? Did you make up 3 points or not?
Yeah.
Okay. Give me a point. -2. Did you already do this? Or okay, so -2 minus 1 makes -3 times -2, so all right. So I just was assuming you had a point. All right, so maybe you guys didn't take the time to make the 3 points. Do you get to how those points are going to be super important when you graph? You can't graph them without a bunch of points. All right, yes?
Oh, why? So, I get like since there's a hole, it kind of gets rid of it, but like if the x plus 4 didn't cancel and you were asked to find the vertical asymptote.
Okay, this is a big
can you
if.
use 4?
If we had vertical asymptotes, it'd be obviously totally different. So I don't like to do that. It'll just confuse everybody. So if I had a completely different problem, yes, it would be completely different. And I'm sorry, I'm being short, but we have a lot to cover. And I think from my experience, when I try to change the problem for somebody, then everybody gets confused about, wait a minute, all of a sudden my answers are all different. So I don't want to change the question. There was none of these, there was none of those. There was an x-intercept though. Selena, where's the x-intercept?
1, 0.
Put in 1. Why'd you put in 1 to find the x-intercept?
Because if you factor the top, that makes the top 0, so you use the fraction 0.
Ooh, you wanted the top to be 0 to get the x-intercepts. Awesome. Normally I say what on the bottom, this gives you vertical asymptotes. I really should start saying or holes. Because the things that make the bottom 0 are either asymptotes or holes. The things that make the top 0 are x-intercepts. All right, how about the domain? Was there anything that would kill this function? You could feed it anything and it was fine?
No, not negative.
Oh, you can't feed it -4. Okay, so the domain is all real numbers except -4. So I draw this, put a -4, empty, fill it in, fill it in. There you go. All right, y-intercept. Finish this sentence for me. Y-intercept is where what? X equals 0. And I can just stick in a 0. I'm going to stick the 0 in here and here. And I get, 0. So it goes through 0, 0. That's another point on my graph. 0, 0. And let me check this. Y-intercept, 0, 0. But shouldn't that have been an x-intercept too? It is. I've just missed that one before. Oh yeah, right here. That's another thing that makes the top 0 is that x there. That makes, if I put a 0 there, it'll make the top 0. So then, yeah, that should have been an x-intercept. There, I think we got it all done. Do you have any questions now about that type of question? Okay. I've been reading some stories, and you know how if you read a story on Google, then it knows that you were interested in that story. It actually even judges how long you're on the page and all that stuff. Well, I read a story about a guy who found a diamond at a national park. There's a national park in the United States where you can go and look for diamonds if you want to, because there are some that are just literally lying out. And it's not like they're all over the place. They're kind of complicated to find and know what you're looking for and all that. But there have been some people that have found diamonds, and it's kind of cool. Of course, they don't look like a diamond in a ring. You know, they're all chunky and they need to be cut nicely and stuff. But we're going to do a problem about that. So we're going to have Bob and Sally and them working together. Okay, so hunting together, it took Bob and Sally 6 weeks to find 2 diamonds. Bob, hunting on his own, found 1 diamond in 4 weeks. How long would it take Sally to find a diamond working alone? Remember, it's always a rate plus a rate equals a rate. I'll pause for a second while you try to put this together. In a moment, you'll be comparing with the kid next to you. And check the kid next to you and see if your equations are set up the same as theirs. Okay, here's what you should know about these. It's always a rate plus a rate equals a rate. Bob's rate was known. It was 1 diamond per 4 weeks. And I mean, they seem like a lot, but you know, if a diamond is worth like $3,000, then that's not too bad. Sally, we don't know, so I'm going to leave it blank for a minute. Then together is 6 weeks, 2 diamonds, and I made that reduce just so it would make your life easier later. And then last but not least, Sally, we want to know how long, so I have an X under the weeks, or maybe I put a W for the weeks. And I want 1 diamond. There we go. And now if you haven't already, you can clean this up and just say 1/4 plus 1/W equals 6/2, which of course reduces to 3. And then I can simply clear the fractions. Oh, question?
You flipped the weeks over times.
Oh, I did. You're right. Sorry. They find 2 diamonds in 6 weeks. Double checking my data. Yes, I had this upside down. Sorry about that. Good catch. So this needs to be 2 diamonds in 6 weeks. 2 diamonds. 6 weeks. 1/3. Okay, now I can clear the fractions out of there. Okay, everybody do that. Who has actually got the answer? Raise a hand if you got the answer. Okay, it's only like 7 people, so take a second and everybody solve that. Okay, so I hope you thought, I'm going to multiply everything by 3. Well, it would clean up one of my problems. See, no more fraction there. Then you multiply everything by 4. I like to just do it all at once. Why have to like rewrite it a bunch of times? And then I'm going to multiply everything by w. Because that'll make this cancel. And the 4's will cancel now. And now I have 3w plus 12 equals 4w. And subtract 3w from both sides. I have w equals 12. Oh my gosh, that worked out. Wait, 4w equals 12. And x. Oh, dang it. Trying to go too fast. Okay, sorry. Subtracting 3w from both sides. Going up, which is weird. Yep. Nope, still not right. I'm really close though. 1w is 12, so 12 weeks it would take Sally to find a diamond. I used my mom and dad's name for that just because, you know, picturing them out in a park finding diamonds. You can see that. They like to pick blueberries. I think if there'd have been a place near them that would have had diamonds, they would have been all over it. Okay, so let me give you another one. How many of you feel confident on that kind of rate problem now? Okay, good. All right, now if you're not confident on that kind of rate problem, catch me at the end when there's some extra time. I'll be happy to do one with you separately. But I got to move on. Okay, our next type of question is kind of like your box problem. Everybody draw a box. I personally start with a rectangle, and then from the 3 corners, here, here, and here, I just draw lines that go straight back, and they have to like all be parallel to each other. And then you disconnect them. All right, so imagine that this is empty, no top on the box, okay? So imagine that it's got a volume is 300. We can just call it, I'll make it centimeters, it wouldn't matter. And then let's say that we're going to call this height. We're going to call this length and this width. Now, what if I say I want the height to be twice as big as the length and width, and I want the length and width to be equal, and the height is double those. You should be able to solve. Now, I know right away at first it's like, what am I going to do? But I hope at a minimum I taught you to start with the formula that's involved, like volume. And you write out the whole volume formula. And then you stick in what you know. We know the volume. And then we know something about length, we know something about width, and we know something about the height. And you should be able to solve it. I'm going to pause for a second while you give this one a try. Okay, would you agree that the volume is length times width times height? All right, so remember, you always start with that. Next, you put in what you know. We know the volume's 300. Well, do we know the length? No. Okay, but we know that the length is equal to the width, so I personally am going to call them both L because they're the same. Now, I could have called them both X. I could have called them both W, but they're the same, so I'm going to put in the same variable form. Okay? And then the height, I know that's supposed to be double L. right? So then I'm going to put in 2 L's for the height. Now, why is this nicer than it was? You can tell me why this equation is pretty good. Yes?
It leaves you with only one variable.
Yeah, there's only one variable. Okay. So then, did you get that?
Yep.
All right. Now, if you didn't, let me give you some thoughts on what you could have done instead. What if you just said volume equals length times width times height, and then what if you said, just replace the volume is 300 in this one. So I get one equation. Can't argue with that. Volume 300 is length times width times height. How about this? Length equals width. Isn't that a true statement?
Yes.
Because it said so. And then what if I had a third equation? Why the third equation? Because if you have 3 variables, you need 3 equations to solve it. I don't know if you've ever noticed this before, but if you only have one equation with one variable, you can solve it. Like that. You could solve that. I only need one equation. What if I had 2 variables though? What if I say this is 7y? Can you solve that? No, you need 2 equations. You need another one. Like, oh, and 2x is equal to 6y minus 7. Now you got a system of equations. You could solve it. What if you have 3 variables? You need 3 equations. So if I'm going to do it this way, there's 2 of the equations. What's the last equation?
H equals 2L.
The height is double the width. So the height is double the width. Or the length. I could have said L. Do you get that this is a system of 3 equations? And what happens when you stick them all into each other? You get that one. So if you couldn't get this right away, maybe you could have got 3 equations. And then you could have used substitution to get it all down to 1. All right. Next one. You've got this dog, and you tie it up alongside your house, 15-minute warning, and its rope is 3 meters long. Do you get that this dog, if you like swing this in an arc, this dog can run kind of around this side of the building, but it can't like go past the building edges? Like, it basically has a big half circle it can run around in. Okay? All right. So, let me see how I could make this. Nope, this isn't going to end up working. This is just too easy. I could ask you for the area that the dog can run in. In fact, I'll just do that. This is just too easy for the test, but this would be like a starter. Okay, so everybody just find the area that the dog can run around in. Well, if I have taught you nothing else, you need to write the formula out all the way with both sides of the formula. Isaac, what is the formula for this? And what did you know?
I knew the radius was 3.
But it seems like there's 3 variables here.
Wait, is that M as in meters or?
That's M as in meters. No, that's not a variable. That's not what I mean.
Oh.
I'm being dumb, but some kids do this. They're like, how do I solve that?
Wouldn't it just be 9 pi?
Yes. You may leave your answer with a pi in it because pi is not a variable. Okay, so 9 pi. But wait, something's wrong.
You divide by 2.
Ah, so really we should have said our area is 1/2 of all that. And then we'd add up 1/2 of this, and our area would be 9 pi over 2. That make sense to you guys? Okay, that was a little too easy.
Wait, why is it 1/2?
Because it's half a circle. The dog can't run over here. Know what I mean? If it had been a full circle, it would have been pi r squared. But it's half of that. Glad you're asking. Okay, so let's do a different wall in your backyard. And this time you decide to put a garden here. We had a problem like this on one of the homeworks, but I got a lot of questions about it, so let's talk about it again. This time, I want it to be long and skinny. Okay, so I'm going to call this the length, and I'm going to call this the width. And I want the length is 3 times the width. I want the area to be 100 square meters. And the question, just to throw it like what they did on the other test, give it a little more complication, is what's the perimeter of my garden fencing? Remember, the red side doesn't count then. Perimeter of the fence around the garden. Perimeter means distance around. Basically, how much fence would you need? All right, I'm going to pause for a second. We work this one out. Remember, it's all about the equations and sticking things into your equations, and sometimes putting your equations all into one equation. I'll pause for a second. In a moment, you'll compare with the kid next to you. Okay, so walk me through it. Amelia, tell me something you know.
The length equals 3W.
I agree. That is one of your several equations you could write, and eventually we can merge them together. Edda, can you tell me one thing you know?
I did length times width equals 100.
So area is length times width would be the beginning of that, and then you put in 100 here equals length times width. I agree. So now I got 2 equations, but I had 3 variables. I had A, L, and W. Is this enough? Maybe this is enough. Can I get it down to 1 variable now? Yes?
No, I was just gonna say, if W was 1, then W would be 3, and then L would be 1. So that
Well,
would-
if W is 1, you can't say if W is 1.
So, no, so then, like, wouldn't it be, like, 3L equals W?
Oh, the length is 3 times the width. Tell me, which one's bigger, the length or the width?
The length.
The length. It's way bigger, right? So wouldn't we have to take the smaller one and multiply it by 3?
Oh, okay,
Okay, you got that backwards. It's okay.
thank you.
All right, so now if length is 3W, then I can replace this length right here with 3W. 100 equals 3W times W, so that's 3W squared. Do you get how you could solve that then? All right, so I just have to divide both sides by 3, square root. You'll have a calculator on this one. Double checking that to make sure I'm right on that. I think you do. Oh, it's a no calculator. Okay, in that case, we would just ask you to leave the answer as like the square root of 100 over 3. So, okay. Any other? Oh, wait a minute. That's the width. I could absolutely see a question where we said, what's the perimeter of the fence? Well, then you'd have to say, okay, then I need to find the length and the width, and then take 2 W's plus an L. And my W I solved right here. I know that answer, but now I got to figure out the length. All right, so wouldn't I be able, once I knew what W was, wouldn't I be able to find the length from just using that? If I know W, I stick it in here and I can find the length, and that'll be easy. Let's finish this one. All right, so I'm going to just finish this off. I'm dividing by 3, and then I have W squared equals 100 over 3. Then I'm gonna go square root, square root. I do get plus and minus, but think about it. Can your width be negative? No. So I can just leave this as the square root of 100 over 3 is W. So W is now square root of 100 over 3. Then what's the length? Well, I can put my width in right here and say length is 3 times the square root of 100 over 3. Can those 3's cancel? Think about it.
No.
No. The square root of 3 on the one side and 3 on the other. You can't cancel those. Question?
Why didn't you just leave it as 100 over 3 for me?
Oh, because we had W squared right here. W times W. Okay? That's why we have W squared is that. So then I got to square root it to get the squared off of there. Yes?
You could put the 3 into the square root and get square root of 300 to make it a little easier.
Oh, I see. So you're saying
Square
you
root.
could square, how about this? Would you agree that this 3 is the same as the square root of 9?
Yep, which is 9 over 1.
And then you could
900.
multiply that in, and then you could have the square root of 9 times 100 over 3. That's all cool, but I would not make you do this, but that's
But
cool.
You could make it 9.
I agree. It works nice. I agree. I know it cancels further. I'm just saying, I don't want kids to be like, oh my gosh, I'm going to fail this test because I didn't see that. The answer would have been fine the way it was right there. Okay, then my final answer would have been my perimeter, which is 2 widths, 2 times this one, plus the length, which we knew back here, and that was 3 times the square root of 100 over 3, which does clean up nicely, Jack, you're right. But I'd be fine with you giving an answer like that, because there's no calcs on this test. Okay. Question?
Where did you get 2 times?
Well, because there's 2 widths. Look at this picture here. Do you get how, if I'm adding up the perimeter, it's adding up this side plus this side plus this side? That's where I got 2 W's. Okay. All right. Last one. And then let me tell you what I would do for homework tonight. I think we should do one with a limit. Let's say I've got a cylinder. Do you get that they have a circle on the top and a circle on the bottom, and then they have sides? Okay. And the surface area of a cylinder, don't worry, I would not make you memorize this, but it's 2 pi r squareds plus 2 pi r h's. This is h. This is r. You with me so far? Okay. Now the volume of a cylinder, does anybody know how to find the volume of a cylinder? The stronger you are at this, the better you'll be on the ACT. They require you to have formulas memorized. They don't give you a formula sheet. Got this one, Jack?
Pi r squared times
Anytime you generally want to get a volume, you want to get the volume of or the area of the base, which is pi r squared, and times by the height. So you are right. Nice job. Okay, what if I said the limit of the function of the height of h of x as, no, it's actually going to be h of r. As r approaches infinity would equal what?
Which one is?
Actually, let's do, I think you'll understand this better. Let's go with volume. The limit, I'll just say limit of the volume. Okay, talk with the kid next to you about what you think that means. The limit of the volume as r approaches infinity.
Oh,
Okay, would you agree as the radius gets bigger and bigger and bigger and bigger and bigger, the volume would get bigger and bigger and bigger too? All right. There is a Schoology quiz, and I strongly recommend doing more practice problems from homework. This test will not be easy. So go do the Schoology quiz and do some more word problems. Have a great day.